All right, good morning, AP Environmental Science. Today we're going to cover topic 6.7, which is on renewable energy. And we're going to focus on a couple of different types of renewable energy. One of them is called biomass, and the other one is called biofuels. And we'll get to those shortly. But I'd first like to just kind of start today just with a review of some of the things that we've talked about the last couple of weeks. So, our major focal point when it comes to energy has been on non-renewable energy. Things like, for example, coal. I'm going to show you here on these next couple slides. Just a quick review, maybe something really good to study and look over before your next quiz or test. Just some of the advantages, the disadvantages, some of the things that are involved with coal, as well as some of the other non-renewable resources. So, for example, coal, the advantages of coal, it's very abundant. We do have quite a bit of it. We're not going to run out of it anytime in the near future. It's easy to transport. We don't have to do much to it in order to use it as a fuel source, even though we probably should do something to it before we use it. And then again, it's the economic backbone of a lot of areas in the United States. Disadvantages: mining can disrupt the land and soil. Whenever you mine for coal, we talk about some of those issues. It's a health issue for miners, especially if miners get trapped underneath the ground. Burning coal is only 35% efficient. So again, it's not the most efficient fuel source, and it does produce a lot of waste, especially solid waste that we have to deal with. Pollutants: it is a very high emitter of carbon dioxide. It is the biggest carbon dioxide producer. Again, that is a greenhouse gas. It produces sulfur, which can turn into sulfur dioxide, which eventually can turn into a component of acid rain. We'll talk more about acid rain down the road, but just understand that coal does have a lot of sulfur in it. Coal ash, I just mentioned this, is a form of solid waste. And of course, a coal power plant has the potential to produce thermal pollution of water when the water gets put back into its reservoir where it actually came from. Now, finally, here on this review, it gives you the EROEI. Remember, this is the energy return on energy investment. And the higher that number is, remember what that number is kind of a comparison of two things. How much energy can you get from that resource versus how much energy do you have to put in to obtain that resource and use that resource. So an EROEI of 14 is relatively high for a fuel source. So the higher that number is, the more likely we're going to want to pursue that resource because it's something that can provide lots of energy with very little input. We don't have to do much to actually obtain it. So I want you to compare that number to these other ones that I go over because that's kind of an important reason why we're probably not going to be abandoning coal in the near future. It's something that we're probably going to continue to use because it has such a high EROEI value. Oil and petroleum, again, some advantages and some disadvantages. And we've talked about a lot of these things in the notes, so you can go back and review those. This is just a nice little concise sheet for you to look over. The pollutants, it is the second highest emitter of carbon dioxide. It does produce sulfur. There are some pros and cons with it, but the EROEI of oil and petroleum is only 4. So since this number is a lot lower, it actually kind of leads us to believe that maybe this is something that we could abandon in the future and maybe try a different fuel source just because its EROEI value is such a minor or minute value. Natural gas. Natural gas, again, pros and cons. We saw the movie Gasland that showed us a lot of the disadvantages of natural gas. Make sure you know that one of the major pollutants of natural gas is methane. Methane is a greenhouse gas that is it's more of a greenhouse gas than carbon dioxide is. So you make sure we know like what the major pollutant there is, as well as all those fracking chemicals and things like that that can actually get into the ground and get into the water. But again, it has the EROEI value that's about 8. So that means it's relatively high. So again, replacing this as a fuel source might be difficult because its EROEI value is fairly high. And then we have nuclear energy. Again, with an EROEI value of 8, advantages are basically that it doesn't really produce a lot of pollution, other than like the nuclear waste issue. Um, the disadvantages of it, again, we talked about these before. If there's any major meltdowns or problems, that those can be catastrophic. People tend to get really scared of those types of things. Um, but again, as far as the pollutants go, not really any air pollution, water pollution, other than maybe thermal. Um, but the pollution aspect is more of just what do we do with that radioactive waste, like from those spent fuel rods, that type of thing. But there's definitely some pros and cons associated with every single one of these. So it's again to your advantage to look over those. All right, so let's today focus a little bit on renewable energy. In fact, for the next couple of days this week, this is going to kind of be the focal point. This picture here, on the right is kind of showing you pretty much every energy resource that we use not only in the United States but also around the world. And again, at the top here, these non-renewables. This is sort of where we were focusing on the last couple of weeks, and now we're going to kind of move into these other types of resources, renewable options. Again, and I think one of the reasons why we should be looking into some of these things is because there are negatives involved with all of these non-renewables, but I really kind of one of the biggest reasons is just the fact that they are non-renewable. I mean, these are things that we could potentially run out of someday. Natural gas, oil, coal. Plus, every single one of these, um, is a major polluter, of our atmosphere or of our planet. So we kind of need to be exploring some of these other options. So the ones we're going to look at, solid biomass, liquid biomass, and they're kind of their own category. I'll explain why that is in a minute. Water, hydroelectric, wind, solar, and geothermal. Now, anytime we're talking about renewable energy, okay, these are things that we can use over and over again. So we're not going to really worry too much about them being, depleted, or we're going to run out of these things. But we do kind of put them into two categories: potentially renewable. These are things that, as long as we're smart, we're not going to run out. Like, for example, wood. I mean, wood is a potentially renewable resource as long as we keep planting trees, right? I mean, Easter Island, let's go all the way back to that, right? I mean, wood was a potentially renewable resource, but they cut down all their trees and they didn't replant them. So that's kind of an issue. And non-depletable, these are things that we don't really ever have to worry about running out of. We're not going to run out of wind or sunlight for solar or hydroelectric or geothermal, which is heat from the earth. We're not going to run out of that. So these are things that we don't really worry too much about running out of. We just have to kind of worry about them providing a consistent source of energy more than anything. All right, so this pie chart here, we've been looking at a lot of pie charts, but on the left, this is again our global energy use. And when you break it down, 86% of all the energy used in the world is non-renewable energy. So again, coal, oil, natural gas, nuclear, that all fits into this gray area. Renewable energy is only about 14%. Now, of that 14%, that's where this pie chart comes in. This kind of breaks down that 14%. 77% of that 14% is what we call combustible renewables, otherwise known as biomass, which is what we're going to talk about today: biomass and biofuels. 15% of it is hydroelectric, and then only 8% of it is solar, wind, and geothermal. So again, of this 14% of the pie, it kind of breaks down this way. Now, if you look at the U.S., it's a little bit different. Um, again, non-renewable, it's about 90%, and only about 10% for renewable. So if you compare us to the world, we use a considerable amount of less renewable energy than the rest of the world does, and we rely more on the non-renewable stuff. Again, oil, natural gas, etc. But even when you break down our renewables, biomass only makes up about 46%, and then you see the breakdown of all the others as well. Okay, so I mean, we do use energy differently, obviously, in the United States. So you should be able to compare and contrast those two graphs. All right, now again, today we're going to kind of focus on biomass and biofuels. Now, one of the big differences between the two is that one is a solid and one is a liquid. A biofuel is a liquid, but biomass is basically any type of fuel source um, that we burn that basically comes from either plant or animal material. That's abundant. It's easy to find. For example, wood, charcoal, which is basically wood, animal manure, peat, even garbage. There's components of garbage that we can burn and we can use as energy. These all kind of fall under the biomass category. But again, they're cheap and they're abundant. I mean, these are things that we can just find very easily. They account for about 10% of the world's energy consumption. Just these alone, these five or six things. In the developing world, it actually makes up a little bit more, just because they can't afford some of the non-renewable stuff. But as far as biomass goes, really what most of this is used for around the world, it's used to just generate heat. I mean, we have the luxury of going home and turning on our furnace, to heat our homes, right? We have natural gas, but probably about 70% of the homes in the world, don't have that luxury. That they have to go home and burn firewood, or charcoal, or in some cases animal manure or garbage, just so they can warm their house and cook their food. All right, so it's a different ball game, in the developing world compared to the developed world. Biofuels are more used for transportation purposes. Two of them that we're going to talk about today are ethanol and biodiesel. They're kind of similar, but they're used as kind of alternatives to traditional gasoline. But I want to go back today and just kind of focus a little bit more on biomass. Anytime you burn, biomass, I don't know if it's a biomass or biofuels, there is a great deal of carbon that gets released into the atmosphere. So again, I mean, if we're burning, let's say, wood, or we're burning charcoal, or we're burning coal, I mean, is it any better than burning those things? I mean, is burning wood or charcoal better than burning coal? Well, there is a major difference between the two, and the difference is, anytime we burn, let's say, wood, for example, wood comes from trees. Those trees were recently cut down. And remember what trees do, right? They store carbon, because they are photosynthetic, so they take in carbon dioxide, they give off oxygen. But that carbon that is in trees, that carbon was just in the atmosphere. I mean, it was just there. That just got recently taken out. So we call that modern carbon, or we call it young carbon, because it was just pulled out of the atmosphere recently. So if you went and you chopped down, let's say, a dead tree or something, and you burned it for firewood. I mean, you're just returning the carbon to the air or to the atmosphere where it just recently was. It's not like that carbon has been out of circulation for millions of years. I mean, it was just in the atmosphere. We're just putting it right back into it. Um, so anytime we burn modern carbon, that's what we call a carbon neutral activity. Carbon neutrality is basically putting carbon into the atmosphere that was just recently there. Now, there's a difference between modern carbon and fossil carbon. Fossil carbon is carbon that hasn't been in the atmosphere in a long time. I mean, for example, when you burn coal, right? Coal is the product of dead plants, right? That were like around when the dinosaurs walked the earth. So when you burn coal, you're burning and putting carbon into the air that hasn't been there for millions of years. So, I mean, this really does alter the composition of our atmosphere because we're burning so much of these fossil fuels and we're putting this carbon back into the air where it hasn't been for so long. That is not a carbon neutral activity. All right. So, two things here. One, make sure we know the difference between modern and fossil carbon and know what the term carbon neutral means. Okay. Now, again, there's several different types of biomass. I want to kind of take a look at three of these today that I think are kind of the most common ones that are used. We'll start with wood and charcoal. Wood and charcoal. Again, it's really easy to obtain. 2.5 billion people around the world actually heat their homes with wood and charcoal. So I mean, think about that: 2.5 billion, right? There's what 7.5 billion people on the planet. So I mean, this is like I don't know, like close to a third of the people on the planet are heating their homes with wood. I mean, that's a lot of people. It is carbon neutral as long as we replant trees. If you don't replant trees, then it's not very carbon neutral. So that's kind of an important thing. And a lot of times people don't replant them after they cut them down. And finally, wood it's cheap. Wood and charcoal are not very expensive. Disadvantages: wood and charcoal burn quickly. We don't get a ton of energy from it. So, like, imagine heating your home with wood. You're going to have a large supply of it. Let's say, for example, if you've got a long winter of 3 or 4 months, you better have a lot of wood on hand because that stuff doesn't last too long. Usually, we burn it indoors, and that leads to health issues, especially lung issues. We do harvest trees, obviously, when we obtain wood and charcoal, which results in clear cutting of forests, uses heavy equipment. Usually, fossil fuels are used in the clear cutting process. It releases carbon from the soil. Anytime we dig up a tree or cut a tree down, we're going to release carbon from the soil. And of course, it also degrades our soil. So there's some disadvantages. Manure. Now, manure is basically animal poop, right? And believe it or not, it's actually used quite a bit in Africa and in India because wood is much more difficult to come by. If you've got people living, let's say, in a desert or in areas where there's no forested land, then they have to have a fuel source. So they actually end up burning animal manure because of this. This picture on the bottom right here, this is basically a wheelbarrow full of poop, that they're going to burn in order to heat their homes or cook their food or whatever. Now, one thing about burning manure is that it does actually have a couple of advantages. One, it removes all the microorganisms from potentially getting into water. In a lot of these areas where they burn manure, um, sanitary water is a big problem. They have a lot of waterborne illnesses. They have a lot of people get sick because they drink water that's contaminated with animal waste. That's all because of the way they don't have modern sanitation. So if they're burning their manure instead of, let's say, putting it into a water supply or allowing it to get into water, then that does actually reduce disease transmission. So that, I guess, is sort of a good thing. Hey, poop is free, so that's like a total advantage, right? Just, I guess, I don't know, shovel up some horse manure and you could just burn it. Some disadvantages: there are pollutants in